Today we're going to continue talking about interest, but today we'll talk about compound interest. Compound interest grows faster than simple interest, and I'll talk about that in a minute. First, interest is still extra money. Even though it's compound interest today, it's still the extra money that's getting paid. So compound interest grows faster. What does that mean? That means if I have a loan of $100 and an interest rate of 2.5% and a time of 10 years, if I have compound interest, I'll end up paying more interest than if I had simple interest. So from the eye of a lender, compound interest is better because you get more money. But from the eye of a borrower, compound interest is worse because the money grows faster. That's because we have the time and the exponent here, so the exponent will make our amounts grow faster than just multiplying in the other formula. Okay. So let's review the letters. We talked about these yesterday, but yesterday we started with I. I is still the amount of interest. It's still just the extra money. A is the total amount of money. It's the ending balance. Okay. P is still the principal, or the original amount of money borrowed. This is the loan amount. R is the rate. So again, we still cannot have percents in the formula. So if you're given a percent, you have to divide that by 100. T is still the time, and it's still supposed to be in years. So if you have months, simply divide that by 12 and you'll have years. Okay. Today what I noticed about the formula is instead of I equals some information, it says A. So today's formula actually doesn't tell us how much interest was being paid. Today's formula is going to tell us what the ending balance is. So yesterday we said to find the ending balance, we had to add the interest and the principal. That's still true. So let's think about what would I do if I wanted to find I. If we wanted I all alone, we would have to minus P from it, or minus the principal. Since it's an equation, we do that on both sides. That'll make the plus principal and minus principal zero out. So if you take the ending balance minus the principal, that's going to tell you how much interest you're having to pay or being paid. So to find I, or just the interest amount, minus the principal from the ending balance. For this right here. Okay, now let's look at some examples, and I'll zoom in so we can see that a little better. First example wants us to find the ending balance on a $5,200 loan that was borrowed for 3 years with a 7% interest rate. This is compound interest today. I know it doesn't say that in our problem, but this is compound interest. That 7% then has to be the rate, but we're not allowed to use percents. So what we're going to do is 7 divided by 100 to change that percent into a decimal. 7 divided by 100, 0.07. Okay. The next number that I'm going to look at is 3, and 3 is attached to the word years, so that is our time. I do not have to divide by 12 because 3 is in years already. You'd only divide by 12 if it was in months. Okay. And it says the ending balance. We need to find the ending balance. So I don't know the ending balance, but there was a $5,200 loan. So the $5,200 talks about the loan information. So 5,200 is for the letter P, not for the letter A. Okay, and we are interested in finding A, the ending balance, which is great. We want to know A, and this formula today is for compound interest, and it's solved for A. So after I solve my equation, I'll have my answer that I want. So we've got A equals P times 1 plus R to the T power. Okay, we don't know what A is, so I'm going to keep A as a variable. We have a value for P, so instead of P, I'm going to write 5,200. There's an open parentheses that I'm just copying down. There's a number 1 that I'm just going to copy down. There's plus that I'm copying down, and then there's an R. For R, we're going to use 0.07 because that's the value for the rate that's not using a percent. There's a closed parentheses, so I copy that down, and then it's raised to the T power. I know the value of T is 3, so I'm going to use the power of 3. From here, all we have to do is type this in on the calculator. So A equals 5,200. Split my screen. Split the other screen. There we go. I just need to type in 5,200 times 1 plus the rate, which was 0.07, raised to the T power, which was 3. So then we've got an answer of 6300.2236. This is talking about a dollar amount, and money only has 2 decimals, so I'm going to have to round to the nearest hundred. Behind the 22 is a 3, so this is closer to being 22 than it is to being 23. So the ending balance is going to be $6,300.22. Just a recap of what we did, we got 6,322 from typing in 5,200 times the sum of 1 and 0.07 to the third power. We got that from the compound interest formula. We're using compound interest formula today because we're working with compound interest, and I just got all of those numbers from the story. Okay. Next problem, and I'll go back to large screen. Okay, this wants us to find the compound interest that is accrued. Okay, find compound interest accrued. Accrued just means the interest that's been added in or grown. Because it says compounded, we know it's compound interest. So find the compound interest accrued, or the interest that's earned on a $5,200 loan borrowed for 3 years with a 7% interest rate. Okay, so the loan amount is $5,200. It's for 3 years. For 3 years with a 7% interest rate. This looks really familiar. It's exactly the same problem. So I know that the ending balance is $6,300.22. Unfortunately, that's not what the question asks. The question here wants to know the compound interest. So we want the interest. We have the total, so we want the extra. We have the total at the end, and we have the original beginning. So to find the extra stuff, we're going to take where we began, which was the principal, and we're going to minus that from the total. The total ending balance was $6,300.22. We have to subtract the principal, which was $5,200. what we're using, what we're doing, I feel like I made this sloppy, but we're just doing this that we talked about up here. To find the interest amount, we're taking the principal away from the total ending balance because that's the extra stuff. Altogether amount minus just what we started with gives us the extra money, and the extra money is the interest, and the extra money is the interest. Okay, so now I'll have to figure that out. Well, that's not so difficult. I can just type it in on the calculator. So we need that number, Control C, Control V, minus 5,200. So the final answer for the amount of interest is $1,100.22. And now we'll look at the third example. The third example says to find the compound interest paid on a credit card after 4 years that has an interest rate of 18% and a balance of $2,000. Since it has a balance of $2,000, I know that the principal or the loan amount is $2,000. It's been paid off through 4 years, so the time is 4. And the interest rate is 18%. I can't use percents, but I can divide 18 by 100. I can do 18 divided by 100 to get rid of the percent. We'll do 18 divided by 100. Oh, whoops. Not like that. And we get 0.18. So instead of 18%, I'm going to use the decimal 0.18. And this wants to know compound interest. This does not want to know the total, but I need the total at the end. This wants compound interest, so I want the letter I. What I'm going to find is the letter A. So I'm going to have to take it one step further and subtract the principal from the ending balance to find I. Before I can do that, this is compound interest. Since it's compound interest, we have to use the formula A equals P times 1 plus R to the T power. Even though I want I have to use the formula that says A because this was compound interest. Well, I don't know what A is, so I'm going to keep A as a variable. And then I'm just going to copy the rest of the formula down, plugging in numbers, substituting the value wherever I see the letter. Instead of P, we know that P has a value of 2,000, so I'll write 2,000 in place of the variable for principal. There's an open parentheses, a number 1, a plus sign, and then there's a variable R. We're using the rate 0.18 because that's equivalent to 18%. So we're going to use 0.18 instead of R. And then the loan amount is for 4 years. So this is an exponent of 4 in place of the variable T for time. So now we just have to plug this in on our calculator. We're just typing, all the typing, always typing, always the typing. So we have 2,000 times 1 plus 0.18 raised to the 4th power. So it looks like this product, this product, 2,000 times the quantity of 1 plus 0.18 all to the 4th power, is 3,877.55552. All of that is equal to A. So this is the ending balance. Again, I'm going to have to round behind 55 cents is a 5, which means 55 cents is really closer to being 56 cents. So the ending balance is going to be $3,877.56. Unfortunately, that's not the final answer for this problem because, again, we were asked to find the interest amount, not the total ending balance. So to find the interest amount, or the extra stuff, we're going to take the ending balance minus the principal or the beginning balance. So we need A minus P. A was 3,877.56 minus P is 2,000. Now we're just going to find the difference of that to get I, or the extra stuff. So we need 3,877.56 minus the original $2,000 credit card balance. So then we know that the interest amount is $1,877.56. And then we've got one more problem. It says to find the compound interest earned on a bank account that has a balance of $11,000 after 2 years with a rate of 1.9%. It does say compound interest, so I can assume that that rate is compound interest. That's got the percent, so I know it's the rate. But I'm not allowed to use 1.9 since it has a percent sign. So I have to do 1.9 divided by 100. And in the interest of time, I'm not going to show you on the calculator, but that is 0.019. Okay, and then I've got 2 years, so T is 2. And then there's $11,000 balance. Since that's the loan balance, that's going to be P, or the principal. And we don't know what A is. Now the question wants us to find the interest, not the ending balance. So I can stop at finding the ending balance if I wanted the ending balance. But I'm not going to stop on this problem because this question doesn't want to know just the ending balance. It wants to know the interest amount. Because it is compound interest, I have no choice. Even though I want I have to use the formula that starts with A because it's compound interest. And the formula that starts with A is the compound interest formula. So I'm going to use A equals P times 1 plus R, all raised to the T power. A is just a variable because I don't know what A is, so I'll keep it a letter. Instead of P, I'll use 11,000 times 1 plus, instead of R, we're going to use 0.019 to represent 1.9%. And then to the exponent of T, which is 2 in our problem because the loan is for 2 years. After that, we just type this in on the calculator. 11,000 times 1 plus 0.019 raised to the second power. That product is $11,421.97. Behind the 97 is a 1, so this would be 97 cents. I would not round up to 98 cents. All of that is equal to A. A is the ending balance, but that's not what the question asked for. If the question wanted the ending balance, this is the answer. The question didn't ask for the ending balance. The question wants the interest amount. To find the interest amount, or the extra, we would have to take away what we started with from the end. What we started with is just the principal. So we'll have 11,000 taken away from that number. Again, in the interest of time, I'm just going to do that subtraction without on the calculator. That is $421.97 for I. And that is the video for compound interest. If you have questions, comments, concerns, please feel free to ask me after class, before class, at lunch, homeroom, all that above, or send me a message on the school sheet.